Friends, in this video I am going to talk about two uh, methods of evaluating project, that is annual equivalence analysis and rate of return method. So to proceed with the annual equivalent method, this method provides basis for comparing investment projects by determining uh, equal payments on an annual basis, or by determining the uh, annual series cash flows. So first, in order to find out the annual equivalent of the cash flow of a given project, first we need to find out the net present worth of the cash flow of the given project, and then multiply this present worth with the capital recovery factor, which is given here. So that is how you get the annual equivalent worth. Why we do this like this is because for most of the projects the cash flows are irregular or uneven. So there is no formula for converting the irregular or uneven cash flow to annual equivalent worth. So because of that, first the cash flow of a given project must be converted to present worth, and then multiply that present worth with capital recovery factor, which is given here, and then you get the annual equivalent worth. For evaluating a single project, these are the decision rules. If annual equivalent worth at the given MARR is greater than 0, accept the investment. If the annual equivalent worth at the given MARR is equal to 0, then remain indifferent. If the annual equivalent worth is less than 0, then reject the investment proposal. For comparing multiple alternatives, multiple mutually exclusive revenue projects, for example, the decision rule is to select the project with the largest annual equivalent worth. For comparing mutually exclusive service projects, the decision rule is to select the alternative with the least annual equivalent cost or least negative annual equivalent worth. So here is an example for you to solve. In this question, you are given the initial investment and the project life is 12 years. There is no salvage value, and it is talking about the savings from annual electricity use and reduced coal use as a result of using variable speed control for the boiler fan. The second and third bullet point is showing the case of geometric gradient series, where the annual electricity use is saved starting with an equivalent amount of Neutrum 14,000, which increases at an annual rate of 4%. The third bullet point is also showing the case of geometric gradient series where the hospital is saving the cost through reduced coal use by 2%, which corresponds to Neutrum 40,950, and the savings increases at an annual rate of 5%. So what you do is first find out the present worth of these two geometric gradient series, and then add them together with the initial investment here and get the net present value. Then this net present value you convert it to annual equivalent worth using the MARR of 10% interest rate here. So that is how you proceed. There is another example for you to solve, which is an example of make or buy decision. So in this case, you are required to choose between buy option or make option. And to do that, you need to find out annual equivalent worth for buy option and make option. For the buy option, you are given the information of the cost of each rotor housing of Neutrum 35, and the company is deciding to produce 120,000 units per year. So if you multiply this per unit cost with the total number of units to be produced, then you get the total annual cost. In case of make option, you are given the initial investment here and the salvage value here, and you are also given the total unit cost of production here. Total unit cost of production. So this total unit cost of production you can multiply with the total number of units to be produced every year, and then you can get the annual production cost from this. So the annual production cost and annual production cost will remain same, and that will already give you the uniform series. But the initial investment here and the salvage value here you need to convert to annual equivalent worth. So for this, as I mentioned before, you need to convert these cash flows to net present value. Then you add up the net present value. Then you convert this net present value to annual equivalent worth at 12% here. Then you can add this annual equivalent worth to the annual production cost. You can total them together and compare this with the annual equivalent worth of the buy option that you found here. Whichever gives the lowest cost will be the option to be chosen. So please try this problem also. If you face any problem, please ask me over the WhatsApp. Okay, so or you can also ask question online through the Zoom. Okay, so we can also sometimes meet online through Zoom. Now to proceed further, I'll talk about rate of return analysis. Uh, uh, the rate of return analysis is many times preferred by many engineers and financial managers because they find it intuitively more appealing to analyze uh, in investment projects in terms of percentage rate of return. Since it is expressed in terms of percentage rate of return, this is a relative method compared to the other two methods that we discussed previously, that is present worth and annual equivalent method. The annual equivalent method and present worth methods are called absolute methods because you get the value of annual equivalent worth and present worth in absolute nil-term values. For this rate of return, there are many other terms used instead of rate of return. So you can see here it is sometimes called yield, it is sometimes called internal rate of return, in short, which is written as IRR, and sometimes it is also called marginal efficiency of capital. So now, what is rate of return? The rate of return is nothing but the break-even interest rate at which the net present worth becomes zero. Or in other words, the rate of return is nothing but the break-even interest at which present worth of cash inflow and present worth of cash outflow becomes equal. Uh, there is another definition for the rate of return which is given here. The rate of return is also defined as the rate of interest that equates the net present worth, future worth, and equivalent worth to zero. In order to find out the rate of return for investment project, first we need to classify the types of cash flows. In order to classify an investment project, what we have to do is we have to count the number of sign changes in the net cash flow sequence. Uh, for counting the sign change, we consider a sign change, or we actually consider that there is one sign change when either the cash flow changes from negative to positive or positive to negative. And please remember that zero cash flow is not counted in the sign change. Okay, so based on the number of sign changes, we can then classify the investment into two different categories. One is simple or conventional investment. Another one is non-simple or non-conventional investment. A simple or conventional investment is one in which there is only one sign change. This simple or conventional investment is further classified into simple investment cash flow if the initial cash flows are negative. Uh, if the initial cash flows are positive, then it is classified as simple borrowing cash flow. Here you can see the examples of simple and non-simple cash flows, or simple and non-simple investment projects. So here, as you see in this case, in this cash flow over a period of 5 years, you can see the cash flow is changing from negative to positive, and there is only one sign change, negative to positive. So there is only one sign change. So this is a simple investment project. Now if you look at this, here you can see uh, the cash flow changing again from negative to positive, and the zero cash flow, as I mentioned before, you ignore. So if you see here, so this is also a simple investment project because there is only one sign change from negative to positive. In this case, the sign change, there are many sign changes, more than one sign changes. Negative cash flow to positive cash flow 1, positive to negative 2, negative to positive 3, positive to negative 4. 4 sign changes are there, so this is a non-simple investment project, and this is also non-simple investment project where you have 3 sign changes: negative to positive 1, positive to negative 2, negative to positive 3. 3 sign changes. And there is another example for you to see. There are 3 projects given here: project A, project B, and project C. So project A has only one sign change, negative to positive. So this is a simple investment project. Project B is a non-simple investment project where you have more than one sign change. Negative to positive 1, positive to negative 2, negative to positive 3 sign changes. In case of project C, it is again a simple project where the sign change is from positive to negative. In case of rate of return, uh, for evaluating a single project, the decision rules are given here. If the internal rate of return or rate of return is greater than the MARR, minimum attractive rate of return, then accept the project. If the internal rate of return or rate of return is equal to MARR, remain indifferent. If the internal rate of return is less than MARR, then reject the project. So in order to find out the rate of return, there are two methods. One is direct solution method, another one is trial and error method. So here is an example given to you. Please try this. In case of direct solution method, you actually solve the equation of present worth. Now you put the values uh, of the cash flows here and solve the present worth equation. So after when you solve that, then you can find out the internal rate of return by solving the equation. Sometimes you come across quadratic equation, so in that case the solution can be found using this formula. So please try this problem. In case of trial and error method, what you do is first you guess the value of the rate of return and put in the equation for solving net present value or present worth. So then you try to solve the equation. If you find the present worth by putting the estimated guessed value of interest here equal to less than 0, then what you do is you lower the interest rate and again solve or repeat the process. Okay, so upon inserting the new interest value, if the present worth is greater than 0, then what you do is you increase the interest rate and you try again and again by changing the values of the interest rate until you get 0 or approximately 0. So whatever interest rate that gives you present worth equal to 0, so that will be the rate of return for the given project. So you can try this example. Another example here. There is another example here. Please try this also. Please try this also. Now, earlier we talked about evaluating single project. Now we'll talk about evaluating multiple projects. So in case of rate of return, like in the case of annual equivalent method and present worth method, we cannot use total investment approach. We have to use what is called incremental analysis approach by finding the incremental cash flows. So in order to compare mutually exclusive projects, these are the decision criteria. If IRR B minus A is greater than the MARR, then select project B. If IRR B minus A is equal to MARR, then select either one of them. If IRR B minus E is less than MARR, then select E, because the project E is better than. So in case of rate of return method, why you cannot use this total investment approach is that no, the selection based on just the internal rate of return actually is sometimes deceiving. So you can see from this example, if you choose the project E1 from project E2 based on the internal rate of return, which is 100% here and 40% here, then you are making a mistake. Because if you look at the net present worth, you see that this has greater present worth. Okay, so in terms of the present worth, the return is higher here or greater here than this project A1, and also the initial investment is different. So if you simply base your selection of the project based on uh, internal rate of return, then it is wrong. So for that, we need to use incremental approach, and to find out to use the incremental approach, first we need to find what is called incremental cash flow. So this you can see from the example in this slide. So you are given the cash flows here for two projects B1 and B2. First you find out the incremental cash flows here, B2 minus B1. Okay, then for this cash flow you find out the IRR. For this incremental cash flow you find out the IRR. So if the IRR is greater than 10%, then select B2. If the IRR B2 minus B1 is less than 10%, then select B1. So another condition for selecting either of the project is that the individual internal rate of return must be greater than MARR. So these two conditions must be fulfilled. One condition is that IRR B2 minus B1 must be greater than the MARR, and the IRR of the particular project which you are going to decide to select also must be equal greater than the MRR. Okay, so please try this problem. There is another problem also here for you to try. Okay, thank you.